What we're going to do first is we're going to walk through October 2016 test 2. It's the one with begins Hooke's law in vector notation. I try to see if I can figure out the version number. It is the rotation version. The rotation is underlined. Number 1. Which law is Hooke's law in vector notation? B. What are the units of coefficient of friction? C. Newton meter. Sometimes I like to jump rails and just ask side questions. Newton meter can be also expressed as a joule. A block is resting on the table. You push down on it. The normal force increases. The force of gravity on the block, if you push down on the block, the force of gravity on the block by the block itself, if you push down on it, does it increase, decrease, or remain the same? Okay, fine, let's not answer this. If your hand has a certain amount of mass, I push down on it, does the mass of your hand, now I'm not touching hands, because it's weird, I'm demonstrating. Does the mass of your hand change? No. So the force of his hand on the table, does it change? Due to just the mass itself. The mass, the mg, does mg change? Because I increase the force down on it. No, exactly. You exactly have the attitude that I'm looking for, which is that little dose of, how dare you, sir, ask me that little bit of question. So this table has a certain amount of normal force. I push down on it. The normal force does what? It goes up or down. Yes. How do I get the normal force to decrease? I lift up on it or decrease your mass or get rid of you. One of the two. That's all it says. You're not sure. No one look at him. Get something. So, vector with the crosshairs, that is a vector doing what? Into the page. Atwood's machine has friction. What is the ratio of E start divided by E end? It's greater than 1. If there is friction, the energy at the end of the motion, is it greater than or less than E start? If there is friction, the energy at the end is greater than or less than the energy at the beginning. Less than. So if you have a big number over a little number, that ratio should be what? Greater than 1. If it was E end over E start, that ratio should then be what? Less than. Question. The percent of energy remaining if it's friction is expressed by what equation? The percent of energy remaining is decided by what? No. Percent of energy remaining, because this was brought up by Daniel. So if you have 10 joules at the end, but you start with 15 at the beginning, how do you calculate? The ratio, you take that ratio and you multiply by 100. So if you start with 15 and you end at 10, the percent remaining is the energy remaining divided by the energy at the start, for 2/3, multiplied by 100, you get 66.7. How do you calculate energy loss? Don't worry, I'll write these equations. Kind of. You can just take that ratio that we got before, the percent remaining, subtract it from 1. Or take a percent, subtract from 100. So, and you get this. Momentum is the product of what two quantities? C, mass and velocity. Thread is being pulled off the spool. This is kind of an important one. The spool revolves at a constant rate. Which of the following is false? C is definitely non-zero. Radial, if that thing has, if it's just rotating at a constant rate, the points at the edge of the spool are still moving. So, if they're still moving, then the radial acceleration will be non-zero. Because what's radial acceleration? V squared over R. Alpha is 0 because if it's rotating at a steady rate, it's not changing, so alpha is 0. Omega is constant, well that's true. Atwood's machine has no friction. Yay, no friction. What's that ratio? If there is no friction, what was the ratio that I was talking about? Look at it. What does it say? Energy at the start over energy at the end. So if there is no friction, say that again. This is correct. It's the same. So if you have two numbers that are the same, the number's 1, not 0. So, circle rotates 3 times in 6 seconds. What's the period? What's the oh wait, oh we're gonna have so much fun today if we can't even get through 9 problems in 8 minutes. 3 times in 6 seconds, what's the period? What's the definition of the period? We're not talking about grammar. Inverse of frequency. Could you give me, without mentioning the word frequency, the definition of period? Not right now. Okay. The definition. Not. I want to hear only English. No letters. No places. How long it takes to spin 1 column. So if it's spun 3 times in 6 seconds, 2 seconds. And now, hold on, getting back to her, if the period is 2 seconds, what's the frequency? You're the expert in period frequency conversion. Object in translational equilibrium means what? It's C. Translational equilibrium means the forces in a particular direction are equal to 0. Which expression represents the unit of work? No. It's B. How you get work, remember one of the definitions of work is force times distance. Force, Newton. Distance, meter. Newton meter. And it has the same units as torque. Torque, force times the distance to the radial, or to the rotation point. Object in rotational equilibrium means what? B. Sum of the torques is equal to 0. 13. Circle has radius of what? What's the circumference of a circle? 2 pi r. Congratulations, you've saved me from having to burn the whole building down. Normal force is blank to friction force. This one, I don't think this one will be in here. But normal force is always what to friction? Actually, it could, because Atwood's machine is going to be true. Perpendicular, yes. Rotational mass is what? Moment of inertia. Unit for frequency other than hertz is what? D, inverse seconds. A rocket spins a disk from rest. What is constant? So a rocket is applying a force to the edge of a disk. So the thing's spinning up. Does it have a constant omega? No, because the rotational rate's changing. Does omega in period change? Yes, because it's spinning up. The frequency increases and the period decreases, which means you've got alpha. Elastic collisions conserve what? B, energy and momentum. On a rotating disk, radial acceleration does what? Points to the center of a disk. Now, one of my more favorite questions. You are running around the circle. You run faster. What does not change? Cricket. A, moment of inertia. Moment of inertia is not dependent upon how quickly you rotate. It just depends on the orientation of the mass. Work has what units? Joules. Units of Units of radial acceleration are what? B. What equation do you use? You get that. Second is the unit for what? Period. Circle rotates 8 times in 4 seconds. What is the frequency? It's 2. So for frequency, you do number of times and how much time. Period is how much time for number of rotations. Can I go back to the last page? All right. And 25, circle dot is a vector doing what? D, pointing, well, actually B, pointing out of the page. All right, next. Now, for something like this, what I'm going to do is if you don't have a copy of this, write it down. So in 30 seconds, I'm going to take this off the screen. If you do have a copy of this, keep it on your desk. What we're going to do is kind of a test simulation. Because a lot of people get confused when it's on the board versus when it's on their desk. And so I just want to do this once where it's only on your desk. So 10 seconds. 5 seconds. Ding, 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 ding. Are we done? Anybody need time? All right. 5 seconds. 4, 3, 2, 1. All right. All right. What we're going to do is the right hand rule. I'll have it oriented in the same way that you guys are. Quick announcement. We meet here on Thursday, here at 2:30. If you are one of the few SDS students that we have, meet me outside my office at 2:15. Probably at 2:20 would be fine as well. And then you can start it over here and I'll go over here. You'll be with one of the graders. So now, F cross A is what? Must be C. F is this way, or I'm sorry, F is that way. A is that way. Points out of the page. Now I have mine laid on the desk, right, like just right in front of me. So F behind me, A to the right, thumb points up. F is this way. Or I'm sorry. See, because the thing is, I'm rotating it in my head. And then, so F is towards the back of the room. A is towards that side of the room. Thumb naturally points out of the page, so it has to be C. Yeah. Don't think about now. You can do it like this, but you gotta hold it like this. There was a student like 4 years ago who said, I can only do it when it's upright like this. So can I hold my test up like this? I need to stand up and do this. And I said, fine, only if I can take a picture. So I've got a picture of a student standing up doing the right hand roll. If I did it, it would be, if I held it like this, it would be F, A, out of the page. The answer is still C. It doesn't matter. But the most common way of doing this is when the test is on your desk. D cross C. D, C is out of the page towards the front of the room, or E. I know exactly. A cross C. F. C cross D. F again. B cross A. Oh wow, I was tormenting these people. F. So it's C, E, F, F, F for that particular word. F, F, F is fine. She feels it. I'm gonna. Sometimes the only winning move is not to play. Walk away. Okay, now, what we're gonna do are the problems. Test review tomorrow. Bishop Hall, main lecture hall. So I think it's 209C or whatever they call it. 1 o'clock to 2:30. So 1 o'clock to 2:30 tomorrow in Bishop. We'll just basically do more problems. And yes, I'll record it. Short of this morning, the overhead projector was broken, and so we weren't able to do we had to do a chalkboard lecture. Yes. Did I not just say the room like 20 seconds ago? The main lecture hall, 209. I think it's 209. It's just the biggest room in the building. So, short of the library, I think. So now, what we have here is we have a disc with a stick welded across it. The length of the stick is 2 times the radius. There's a force at the edge so really what's going to happen is that stick and the stuff is going to spin up. It rotates 50 times in a time of 20 times the square root of pi. Which, in other words, I desperately needed a pi within this equation in order to get the numbers to cancel out. If the mass of the disc is 120 kilograms and the mass of the stick is 20 kilograms, what is the value of R? So this is a situation where you do have a force on a circle and it's spinning up. So in this particular case, you've got to just, when you see this reflexive instinct, sum of the torques is equal to 0, theta equals theta naught plus omega naught t plus 1/2 alpha t squared. Now you know some of the basics. Torque is the force times the distance, or whatever it is from the force to the rotation point. So that's going to equal Fr, because d in this case is equal to R. So the sum of the torques, oh actually I apologize. It's not 0, it's I alpha. If there was no force like this on this rotating disc, that would equal to 0. But there is a force, so it doesn't equal to 0, it equals to I alpha. So there's only one torque, so Fr is equal to I alpha. Theta is equal to 2 pi n. Theta naught and omega naught are both 0. Theta naught is always 0. There's only one case in a lecture where it's not going to be 0, and you won't be tested on that particular part. Omega naught is 0 because it starts from scratch, which leaves you with 1/2 alpha t squared. I'm only interested in finding R. I do not care about alpha. I don't know what alpha is, but I don't ask for it. So what I'm going to do is I'm going to merge these two together. Fr over I is equal to alpha, so 2 pi n is equal to 1/2 Fr over I t squared. So alpha got substituted out, and now this is the equation we're going to work on. I know N, F, looking for R. I know T, but I don't know what I is. That object is composed of two different objects that are welded together. A stick rotating about its center and a disc rotating about its center. Like mass, you add moments of inertia together. I of the stick, 1/12 ml squared and 1/2 mr squared. L is equal to 2r. So this is 1/12 and you get this. That's the moment of inertia of the object. You put that in here. Yes. All right, hold on just a second. So you're wondering what went on between here and there. L is equal to 2r. So L squared is equal to quantity 2r, closed quantity squared, or 4L squared. So that L, there's a middle step, 1/12 ms 2r squared plus 1/2 md squared, or md r squared. So that 2r becomes a 4r squared. 4/12 is 1/3. Does that explain it? Okay. Now I look for R. That R pops up to the left. I have an F over here. I have a 4 pi n. That 2 comes down and makes this. ms over 3 plus md over 2. And now it's plug and chug time. And what? Oh. What did I do wrong? Where's my t squared? There it goes. Now, plug and chug. F 140. T squared. T is 20 times the square root of pi, so this becomes 400 pi. 4 pi n. N is 50. Mass of the stick is 20. Mass of the disc is 120. Pi cancels with this. 50 times 4 is 200. 400 divided by 200 is 2. This leaves me with 280 divided by, I'm feeling kind of uncomfortable that this is going to work. 66 2/3. Oh, I'm awesome. 4.2 meters. 4.2 exact. Like I had planned it. The sign that I have planned the number is the time 20 times the square root of pi. That's me telling you I'm desperately trying to get the numbers to work, and that's the only way that I could. Question.
At the top of that left page, so you multiplied by 2 on the left, get rid of the 1/2, and then moved it back under?
No, what I did is I brought the 2 pi in down, and since there's a 2 there, the 2 pi in becomes 4 pi in. This r that's hanging out in the denominator that was r squared but canceled with this r, I took that and brought it up. So effectively, I multiplied both sides by r over 2 pi n is really what I did. Does that answer it? Okay, good. Because sometimes I see that 100-yard stare and then I go, I need to make sure.
That 280 over 66.67.
280 over 66 2/3. And you get 4.2, that's it. Okay, number 2. Atwood's machine, excuse me. The missing variable is mu sub k. M1 is equal to question mark. That doesn't mean I'm asking for the mass. I'm just telling you that it is unknown. And if people ask the question, well, why didn't I not give the mass? I would say it is a correctly constructed problem. I'm looking for 2 specific values, mu sub k and the fraction of energy remaining. So really, I'm looking for energy final over energy initial. All right, next. Yeah, I could see how that's confusing with both question marks, but I say I only want what's in the box. So, there is friction, boo friction. Energy initial minus energy removed through friction is energy final. The initial state, not moving, only potential energy, no kinetic. So it is M2GL. We'll worry about the work in a moment. The energy final is only the final kinetic energy. So this is 1/2 M1 plus M2 V squared. Now getting back to, let's go through all the motions that this thing has. M1G, normal force, friction force. Sum of the forces vertically is equal to 0. It's not moving up or down. Normal force minus mg. So, and these m's we need to pay attention to, m1g. So normal force is equal to m1g. friction force is mu sub k times normal force. So this is mu sub k m1g. I want you to go through all the motions on this derivation. The work, which is force times distance, is mu sub k m1g times its distance. If that falls L, that moves L, you get that L. So now we plug this in. M2GL minus mu sub k M1 GL equals 1/2 M1 plus M2 V squared. And now this is at the point where most students just fall apart and cry, because I didn't give you the masses. But what I did give you were the ratio of the masses. I said that M2 is 4M1. This gives you 5M1, or 5/2 M1, and there's an M1 in every term. So this becomes 4GL minus mu sub k GL equals 5/2 V squared. I'm looking for mu sub k. 4GL minus 5/2 V squared is equal to mu sub k GL. For GL minus 5/2 V squared divided by GL is equal to mu sub k. Now the first thing that you would want to do if you had the time is to showboat it and show how the units work out. G is in meters per second squared. Length is in meters. V squared is meters squared second squared. And the denominator is m second squared m. So you've got meters squared second squared minus the same thing divided by the same thing. All the units cancel. Which gives you nothing in terms of no units, which is exactly the units that you need for coefficient of friction. Now plug and chug. 4, 10, 40 minus 5/2 24 squared, 10 times 40. Ooh, let's see, 40 times 40, that's 1600, I think. Yep. Minus 2.5 times 24 squared, 160 divided by 400, and I get 0.4. Oh my goodness, once again, a whole number. If you guys leave me alone tomorrow, I can work on the problems and I can make the numbers work out nice. The more you bother me tomorrow outside of that review session, I'll just whip stuff together and who knows what we're gonna get. So that's just slang for do me a favor. There are many resources that you can pursue. I'd like to spend my resources on writing a decent test. So that gives you the ratio. The last thing you need is the fraction. The energy initial is just M2GL. The final is the kinetic energy, M1 plus M2 V squared. M2 becomes 4M1. Denominator becomes 1/2 M1 plus 4M1 V squared. That 2 comes up, becomes 8. M1 plus 4M1 is 5M1. And once again, the M's cancel. And you're left with 8 times 10 times 40 divided by 5 times 24 squared. 40 divided by 5 is 8, so 64 times 10 divided by 24 squared. Now, it's difficult to get all the numbers agreeing perfectly. So it is, ooh, wait. What did I do wrong? It should be E final over E initial. I have E initial over E final. So really all you got to do is take it and invert it. So really the answer that I'm looking for is 5b squared over 8gl. And that gives me, because I did plan on doing this, 0.9 perfect. Because the answer that I got, I'll get to you in a second. The answer that I got was 1.111. And I knew that the answer, or the question asked for fraction remaining. If you get a number greater than 0 for fraction remaining, you've messed up. And so I immediately went into search mode and realized that it should be this. Yes.
Can I ask you to pull it up a little bit?
Okay. For lecture directions, just say, pull it up, please, and then I'll go, okay. A worthy question. What are we talking about? EF over E initial? Or E initial over EF? Is that what you're asking for? I'm not hunting you down. I'm using you as an example. Just as a learning. Just singe the hand just a little bit. Just to make it remember. What was the question about? The question was the ratio. Ratio, what numbers did I have to use? I had to take a final energy and divide it by the initial energy. So the answer has joules over joules. So the final unit is nothing. So the final answer is just 0.9. With no unit. I'm trying to help you out here. You don't even have to write units down. The mistake would be to write units. Because all fractions are, is just a ratio. It's just a number. All right, problem 3, torque bar. Oh, I could see how this works. Okay. So the torque bar So the first thing we got to do is we got to set this thing up. What do you know? Well, a valid question that you could ask is this thing moving? And my answer would be, oh goodness, I hope not. Dr. Eschenberg has, on occasion, given torque bar problems that are insolvable, or they give nonsensical answers. Dr. Eschenberg is extremely paranoid about problems that won't work out on tests. So Dr. Eschenberg will be working on a torque bar problem that's new and will work. That's why I specifically made M1 an unknown and I gave you F. Because with that particular, you can't destroy that type of problem. And it's not moving, so you know what? You know two things. One, it's not moving up, down, not moving left, right, not moving forward, back. The left, right, forward, back are kind of nonsense or unimportant. But you also know that the thing's not rotating. Now in this particular case, I gave you the force at the fulcrum. So you're kind of sitting there going, well, what do I do now? In addition to it not rotating around that point, is it rotating around that point? No. That would be crazy. So you also know for a fact that some of the torques around A is 0. Because if the bar ain't moving, some of the torques are always 0. So if we choose this as the point, I'm allowed to ignore tension of the string when summing up my torques. Why? Because the distance of the force to the rotation point that I'm using, that distance is 0. So you don't have to use it. But there are 3 other forces. There's M1G, there's F, and then there's M2G, where M1 is the unknown. Next, we need to determine our distances. And when you determine the distances, you must use from the force to the rotation point that you're using. It's not always from the force to the fulcrum. So in this particular case, you've got 3 forces. First force, M1G, what is the distance from M1G to A? It's just R1. What's the distance from F to A? R1 plus R3, yes. And then the last force, M2G, what's the distance from M2G to A? It's the sum of all 3. The other valid point that you can use to sum up torques would be that point right there, because that's your other unknown. Had you chosen that point, you would use that, and that as the forces, and then the distances would change. Now, you have to use the right-hand rule to determine sum. You always start from A and go to the force. So for the first torque, the force is to the right of A and down. That's into the page for negative. F is to the right. F is up. Thumb points out. So that's positive. M2G to the right. Force is down. Thumb is in. That's negative. So it's negative, positive, negative. I need to know this. Who did not see that? Okay. So when you do torque, the torque is a right-hand rule. You've got to use the radius. So force is pulling down. Because M1G is down on the page. So now, which direction is my thumb going? Into the page. What's into the page? Positive or negative? Negative. And yes, correct answer, wrong tone. It's negative. Actually, you can say it's Bugs Bunny. Say it with conviction, all due respect. So now to the right, down, in, negative. Now the second force, F, is to the right, right down. But in this case, the force is up. I can't bend my fingers up, so I have to rotate my whole hand and rotate the fingers up. So the thumb comes out of the page. So that means out of the page, positive. And then the right one, the last one, all the to the right, force goes down, thumb comes in, and that's how you determine it. The whole point of the right hand rule is just to determine sum. And so that's it. I'm looking for M1. To the other person who raised their hand, you understand it now? Or you at least kind of get an inkling of it? Okay. All I'm looking for is M1. That's the only unknown. Zero equals this plus this minus that. Yes. $300 times 5, 1,500 minus 100 times 6, so minus 600 divided by 20, M1 45. Oop. And just because I'm interested, has the Ole Miss baseball game ended?
Yes, we won.
We won? Excellent, good. I would never go there because there were 5,000 children. So I just watched it from a distance. Last thing, you got to figure out what the tension is, because we discovered what M1 is. Now, we use the sum of the forces vertically. We could do this in all sorts of different ways. We could pick different torque points. We could do some of the torques and then some of the torques again, where we could choose that as the rotation point. What I feel is that it's more simple or simpler to sum up the torques first and sum up the vertical forces. It's just the math is easier that way. So T plus F minus M1G minus M2G, and that again all equals 0. I'm looking for T. So T equals M1G plus M2G minus F. So this equals 45 times 10 plus 7 times 10 minus F 300. 450 plus 70, 520, 520 minus 300, 220 newtons. Oh, did it? Whoa. 450 plus 70 minus 300, 220.
That's 2 is 10.
Oh, did I get M2 wrong? Oh, crud on a blah, blah, blah. Were you guys raising your hands for the last 2 minutes as I was doing this? So that would change things. I'm still good. It's 54. Is that what you guys get? Yeah. Okay. 54 times 10 plus 70 minus 300. That gives me 310. And one of the advantages that you have with the alphabet soup method, 1 and then 2, is that if I figure out I inputted a wrong number, I can just go to the plug-in equation, change the one number, and then the thing just works. Yes, number 1. Where did the 7 come from? No. Oh. And now I remember the error on the test. If you look at the test, I had M2 is equal to 10 up here and M2 is equal to 7 down there. So it was an error I made 6 months ago has hunted me down and found me. Was that your question? What's your question? Did I? If I chose to give you what? I don't think I would ever give you the torque as numbers. I would give you forces as numbers and distances and masses. No. Honestly, in the history of the 7 years that I've taught this course, I've never given the torque as numbers. Because generally torque is figured out by force and distance. So then you would just write in the number rather than force and distance. I don't think this is one of those things where it's best to keep quiet right now because my brain is sitting there going, no, I need to stop that brain. So we're keeping it to the 213, and in particular 213 in the spring is a very conventional, straightforward class, and I don't like to get cute, but or snarky. If I was in honors, then I would be all sorts of snarky. Other questions over here? Any other questions on this? All right, what we're gonna do is if you want to talk to me, I'll have office hours for the next hour or so. This video will get posted, and I will see you tomorrow, 1 o'clock, if not online, in Bishop.